Well, yesterday we have gone with some certain basic concepts about the cloud. Okay, we have gone with the in detail discussion about the syllabus. Okay, so we were discussing about service models, deployment models, essential characteristics which are being exhibited by the cloud. Okay, so essential three, that's nothing but three, four, five. Okay, in general. Okay, there are many service models, there are many deployment model, but in general we have to talk. Okay, so three, four, five. So what is the three, four, five in a cloud? We come across three service models. Okay, four deployment models and five essential services. So what are the service models that we come across with respect to a particular cloud in general? So these are the basic things. Okay. So software as service, platform as service, infrastructure as service. So next deployment models. Okay. So we come across generally four deployment models. What are they? Public cloud, private cloud, hybrid cloud, and community cloud. Okay, next essential characteristics. So these are the five essential characteristics that we come across with respect to the cloud. What are they? On-demand self-service, broad network access, resource pooling, rapid elasticity. Okay, so let's discuss in detail about these things. Okay, one by one. So service models, as we have said, na. So service models is nothing but of three types: infrastructure, platform, and software as service. See, in previous class we have gone with a difference between on-premises cloud environment and with respect to a cloud. That means what? If we are maintaining everything with respect to on-premises, what are the drawbacks that we come across? And if we are maintaining the same with respect to the cloud, what are the more advantages that we come across? So in previous class we have discussed these concepts elaborately. Okay. So now see here, on premises. See, on premises, when we talk about on premises, see, what do we come across there? We have to maintain application, data, runtime, middleware, operating system, virtualization, server, storage, networking, entire thing, okay, has to be taken care by the uh, premises on premises experts itself. Okay, when we go with these services, what are they? Infrastructure as service, platform as service, and software as service. So just have a look here. When we talk about infrastructure as service, okay, when we talk about infrastructure as service, okay, when we take this service as infrastructure as service from a particular cloud. See, there are two things. A color diagram represents two things. What are they? One is with this pink color, another one with this blue color. So blue color are nothing but the managed by the vendors. Okay, and this pink color is nothing but managed by ourselves. When we talk about on premises, what do we observe there? Entire thing has to be managed by the people itself in who are maintaining the network. Okay, applications, data, runtime, middleware, operating system, virtualization concept, server, storage, network, entire thing has to be carried out by the people. Okay, with respect to the premises. Okay, so when suppose an end user, an organization has moved to a particular cloud, and they requested for infrastructure as service. Okay, so with respect to infrastructure as service, so when an end user enroll himself with respect to infrastructure as service, what are the various services given with respect to the cloud for the end user? Okay, with respect to infrastructure. Okay, the cloud vendors can provide virtualization. Okay, they are going to manage the servers, they are going to manage the storage, they are going to maintain the networking. Okay, so with respect to infrastructure as service, what are the things that the people have to manage there? Okay, with respect to the organization experts has to manage the applications, data, runtime, middleware, and operating system. The remaining entities are being managed by the cloud service providers or the cloud vendors. Similarly, next, suppose if an organization is going to be offered or they are requesting for a platform as service. So what are the things that they have to manage, and what are the things that is the which are going to be managed by the vendor? So the blue color, the color variation itself shows. See here, uh, when we talk about infrastructure up to virtualization concept, okay, the cloud vendor itself take care. When we talk with a platform as service, so beside or up to virtualization, they also take care about the runtime, okay, the middleware and operating system. When I talk about software as service, so everything has to be taken care by the vendor. There is nothing else. So an end user or an organization, simply they can access the services and they have to pay for that. Okay, so let's make the concept more clear with a live example. Am I audible? Am I viewable?
Yes,
Yeah,
sir.
yeah, very good, very good. Okay, thank you. See, just suppose we want to make a cake. Okay, let's take a live example. We want to make a cake. Okay, so see, one thing is that suppose uh, we are making a cake at home. That is nothing but the on premises. If we have a look here, what do we observe? We are having a dining table, water, electricity, oven, okay, cake pan, flour, the ingredients required for the cake, sugar, butter, eggs. So everything we are having at home. So I can make the cake. So that is nothing but on premises. Suppose infrastructure. That means what? I am having some contents. I have to bring some contents from the market. So what are they? The ingredients which are required for the to make a cake. The flour, okay, and sugar, butter, eggs, that I have to bring from outside. Next, suppose if we are going with a platform as service, so beside that a customer is having only dining table, water, and he is going to purchase the remaining thing: electricity, oven, okay, cake pan, flour, sugar, butter, okay, eggs. So what is next thing? Suppose software as service, so nothing else. An end user has to no worry. Okay, there is no worry with respect to the end user in order to maintain all these things. So what is the best example? He can go out for a restaurant, or okay, he can just order the cake and he can just finish and pay for that. So similarly, the software as service is nothing but of the same scenario. If you if an end user is going to offer software as service, by default they are going to be provided with platform and infrastructure as service. Okay, you can have a look here. Okay, so now you got a clear cut idea about the various service models. Okay, infrastructure, platform, and software as service. Okay, so this is a one live example we can have it, so that we can remember the concept very easily. Next, deployment models. When we talk about the deployment models, see, in deployment models, we are having various kinds of clouds there. Okay, so we can deploy the model with for a public. We can deploy the model with respect to only an organization. We can deploy the model of a cloud with respect to a combination of both public and private. We can deploy the model with respect to a particular community. So basing on that, the deployment models can be classified into four types. What are they? Public cloud, private cloud, hybrid cloud, community cloud. When we talk about a public cloud, for example, consider a bus. A bus is there. Okay, let it be a public cloud. So everyone can utilize the service and they can pay what they are utilizing for that. Okay, so that is nothing but a public cloud. For example, private cloud. Private cloud is nothing but suppose our college is going to have a its own cloud. So who can access? Only the college persons. That means what? It comes under private cloud. That means it just resembles that we are having a own car. Okay, so who can access? We only can access that one. So, and is there any possibility for outsider to access the car? No. Okay, so next, hybrid cloud. So what is a hybrid cloud? Hybrid cloud is nothing but we are enjoying all the facilities, but the entire entity does not belong to us. So how much we are using, we are just paying for that. So here, what do we observe in hybrid cloud? So everyone can hire a taxi. Okay, so they can just reach to the destination from their source and they can pay for that. Okay, so if I took the ride, it doesn't mean that the car belongs to me. Okay, so like that, everyone who can hire the car, so they can go to it. That is nothing but hybrid cloud. Next, when we talk about a community cloud, so community cloud is nothing but they are relevant to a particular group of community. So if an example, a school bus is there or a college bus is there, who can access that one? Only the persons who are belong to that student community. Suppose a cloud is made, a cloud service is made with respect to doctors. Who can access that one? Or what are the content that are present with respect to that doctor community cloud, with respect to the various diseases, with respect to the information about the patient, and so on. So that means what? A cloud services which are dedicated for a particular, okay, community, okay, student community, doctor community, teachers community. So like that. Okay, so that is nothing but a community cloud. Okay, so now we got an idea about the deployment models. So generally four types: public, private, hybrid cloud, community cloud. And perhaps when we talk about the security, so there is a lot of variation with respect to the security. Okay, we can expect for private cloud more security compared with that of the public cloud. It doesn't mean that there is a zero security in public cloud. No, somewhat security is provided, but the levels of security when we compared with that of the public and private, in private we can have more. Okay, so similarly there are certain variations. Okay, so depending upon the need, depending upon the services that we have to take, okay, an end user can prefer either with public, private, hybrid or community cloud. Okay, so these are the examples of deployment models. Next, the five essential cloud services. Okay, so what are the five essential cloud services? On demand, broad network access, rapid elasticity, resource pooling, and measured services. See here, on demand self service. So when and where we require a particular service, once we are enrolled in the cloud, we can hire that particular resource. Okay, if we can make the demand, that means what, this is the requirement, I want to run this application, for that I need a operating system, I want to run this application, for this I need this kind of architecture for which the configuration is so and so. So depending on the need, once a user has enrolled with respect to the cloud, he can demand for the resources. Okay, he can utilize that one. Okay, until unless he can hold those resources until he has completed the task, and then uh, he can just reveal that one. So in on-demand services, self-services, what do we observe? How much we have used? Okay, what is the demand, for which resource we are demanding, that we can hire from a cloud. Okay, next, broad network access. As we have said now, once we are connected to a cloud, okay, so that means we are going to be access, or we can access throughout the world. Okay, so that is nothing but a broad network access. Next, rapid elasticity. In yesterday's example, we have gone with one live example, that is nothing but the maintaining of those e-commerce sites. Okay, maintaining of the e-commerce sites. So what do we observe while maintaining an e-commerce site? So the best example what we give, a Flipkart. Okay, a Flipkart on a particular occasion day, so that is nothing but on a big billion day, so there is a huge traffic on the website. So here what happens, so depending, we cannot estimate that only 10 lakh people will access or 25 lakhs people will access. So depending on the demand, we cannot allocate the resources at a time. Okay, so here once such kind of users are enrolled with a cloud vendors, so everything is going to be automated there. So as the demand increases, the resources are being increased. As the demand decreases, the resources are being decreased. So that means what, there is an elastic nature with respect to the resources. Okay, what an organization or end user is using. So depending on the uh, traffic, or depending on the need, okay, we can just increase the number of resources. So if the need is not there, much need is not there, so just access this Flipkart site now, so there is not much traffic. Okay, we can easily put the order. Okay, so there what do we observe, the traffic is not much, so we do not require more resources, more servers to be maintained at this point of time. But imagine the same on a particular occasion day, so there is a huge traffic that has to be maintained. Okay, so in order to maintain that huge traffic, what we are observing, so huge resources are required. So that is nothing but increasing or decreasing of the resources. So that is nothing but increasing and decreasing means what, it just ensembles or resembles a elastic nature. So that is nothing but rapid elasticity is there. Okay, so depending on the demand, depending on the requirement, okay, we can grab as much as resources we can. Okay, next, resource pooling. So once we are enrolled in the cloud, every we are going to be provided with any kind of resource. Okay, it doesn't mean that the latest softwares are not available, it doesn't mean that the high end configuration is not available. It's not like that. Okay, everything, once you are enrolled in a cloud, there is a n number of resources, n number of services within the pool, uh, which are going to be distributed to the end user depending upon the requirement. That is nothing but the resource pooling. Next, measured services, or this is also termed as metered services or measured services. What do we come across with metered or measured services? Metered services or measured services means how much we are using, pay for use. Okay, pay for what you have used. Suppose you are connected to a cloud, and your organization is having 100 systems. but not all the 100 systems are being utilized at the same time. For 20 or for 1 week, 50 systems were connected to the cloud to carry out the task. On another week or another 2 week, remaining 75 systems were connected to the cloud. So first week, how many? 20 connected. So bill is going to be generated with that. Next 2 weeks, how many? 70 are connected. Bill is going to be generated with that. It is not like that once you are enrolled in the cloud, though you are utilizing or not, you have to pay. It's not like that. That is nothing but called as the metered or measured services. So pay per use, pay for what you have using. Okay, so that is nothing but, so these are the 5 essential characteristics: on-demand self-service, broad network access, rapid elasticity, resource pooling. Okay, next measure. Okay, so these are the 5 services. Next, the important concept that we have to learn with respect to a cloud is nothing but see how cloud is going to provide all these services. So the basic principle basing on which cloud is working is nothing but the concept of virtualization. Okay, let's make the concept more clear with a diagram. Now, if we talk about a traditional architecture, see what do we observe? We are having a hardware on which okay, operating system is there. We can run the applications. Suppose consider our laptop itself. So maximum we can have 2 operating system, but we cannot access 2 operating system at the same time. We have to switch from one to another. Okay, but consider the case when you require to go with more operating systems. So it is not like that. Nowadays we can carry out such kind of thing with the concept of virtualization. So virtualization is nothing but the basic principle, okay, okay, on which the cloud concept is being working. So that is nothing but in this operating system when we compare a traditional architecture with that of a virtual architecture, what do we come across? So this is the operating system. Okay, so here there is a virtualization layer. So virtualization layer, on a virtualization layer we can have our n number of systems. That depends upon your laptop configuration. If you are having a high end configuration, you can create nearly 10 to 15 virtual machines. Okay, you just install one virtual machine with Windows, another with Linux, another one with another OS, Mac OS. Okay, so like that. So how could it be possible? You are running, okay, different kinds of operating system in a single system. How could it be possible with respect to virtualization concept? So virtualization is nothing but we can say that that is the basic principle on which a cloud computing is going to work. Okay, so here a software is required, okay, to have that virtualization. Okay, so those softwares are nothing but termed as virtualization softwares. So what are the examples of the virtualization softwares? We can term that one as VirtualBox. Okay, VirtualBox is there. Next, VMware Workstation is there. Okay, Microsoft V Hypervisor, virtualization hypervisor software is there. So depending upon the need, you can install or run the virtualization software. So now, what is the simple definition of virtualization? It is the process of running a virtual instance of a computer system, okay, in a layer abstracted from a actual hardware. See, if you just have a look there. See, now when you go to the concept of virtualization, the hardware is same. That means if you run any kind of virtual machines in your laptop with this virtualization software, they are going to access the same hardware is same, okay, but the number of virtual machines you are creating, those are utilizing these hardwares. Okay, the single hardware that is present with respect to your machine. See here, we are having a single machine, then also we are able to run multiple machines on that one. We are having a single laptop, then also I can run, okay, one virtual machine with Windows, another virtual machine with Kali Linux, another virtual machine with Ubuntu. Okay, so in one system we are going to carry out a number of things here. Okay, see, I'll just show you one example. See here, VM Workstation. So this is one kind of hypervisor that I have installed. See, as I said now, so in order to require a virtualization, what do we require? We require a software. That software is nothing but termed as hypervisor. You just have a look here. See, three machines I am running, okay, on my single laptop. So I have installed, okay, one virtual machine I have installed the Windows Server operating system. Another one I have installed the Ubuntu. Another one I have installed the Kali Linux. Okay, even I can run all the three at a time. Okay, so this is the, see, we can carry out the concept of virtualization in the laptop also. Okay, so this is one example that I want to just show to you. Okay, so what, three virtual machines I am running here. Okay, one is with respect to Windows Server, another one Ubuntu, another one Kali Linux. Okay, see, that is the basic principle of the virtualization. If the virtualization is not there, you could imagine, suppose you want to run three machines with three different operating system, you have to buy, that means we have to pay, okay, we have to buy three machines, individual machines. So cost is more, we have to invest more to carry out the task. But if the virtualization concept has reduced the cost, in the same virtual, in the same okay, physical machine, you can run two or three virtual machines at the same time. See, with respect to performance, there is no difference. Okay, so how you are running your laptop with a single operating system, the same performance can be achieved with the virtual machines also. Okay, so that is the scenario of virtualization. See, the same thing what I said, this is a single desktop, and once it is being virtualized, okay, so see these three virtual machines uh, that we have created there, okay, as the example, CentOS, okay, another one Kali Linux, okay, another one Windows Server, okay, Ubuntu, whatever it may be, whatever the operating system that you require, okay, you can install that one. But there we have to use ISO files. You can download the required ISO files. So find the compatibility of your system, whether that is 32 or 64. So with respect to that, try to install the ISO file, and then you can run the virtual machines. Okay, so this is how, so the concept of virtualization is being carried out. Okay, so now let's go to unit 1. So let's have the contents here. Yesterday we have discussed system modeling, clustering and virtualization, scalable computing over the internet. When we have in detail, so these are the topics that we have to cover: scalable computing over the internet, okay, technologies for network based system models for distributed and cloud computing, software environment for distributed systems and clouds, performance, security and energy efficiency. So let's go with the first one. Okay, scalable computing over the internet. So scalable computing over the internet, so we have to go with the age of internet computing, scalable computing trends, and next, internet of IoT and cyber physical systems. So let's have a look for the first one, the age of internet computing. So Linpack benchmark. See, we have observed that now we are running with the cloud computing concepts, but we have to make a uh, comparison, or we have to go to the extent, and we have to say that yeah, well, good, the performance of this cloud computing is good, or the performance of the cloud provided services are being good. So how can we justify that one? So we require a benchmark, that means we require a measure for that. So Linpack has suggested two benchmarks in order to measure the quality, in order to measure the performances of a cloud services. So what are they? He suggested two concepts. One is HPC, another one HTC. High, okay, high throughput computing, high processing computing. Okay, high throughput, high processing computing. Okay, performance. Okay, high performance or high throughput computing. You just have a look here. See, we are using the cloud services. Okay, uh, an end user makes a request for the cloud, and he grabs the required resources, he completes the task, that's well and good. But how to measure the performance, whether the services which are being delivered by the cloud to the end user are up to the extent? So in order to measure that one, there are two benchmarks for that. One is high performance computing, another one is high throughput computing. So both the concepts are different. In high throughput computing, we are giving importance for the how much of output we are getting. In high performance computing, So we are giving importance with respect to performance. Okay, so both the concepts are important. So some of the application require more output, some of the application require more performance. Suppose if we are dealing with a scientific application, okay, a medical side applications, okay, so for that there is a lot of work that has to be analyzed, lot of comparisons has to be carried out. Okay, so for them what happens, we require high performance, not high throughput. Okay, uh, with respect to any applications which we are running, in certain cases output makes the content. Okay, that means what, we need more output. So depending upon the need, whether we have to go with throughput, more output, or more performance. Okay, so these are the two parameters basing on which we can measure the performance of a cloud. One is high throughput computing, another one is high performance computing. Okay, so if we had a look at the history of the cloud computing in previous class, see, we have gone with a graph. See there, from 1960, okay, the concept has been emerged. So that means that was the foundation era. So when we come to 2000, so completely the complete taste of cloud was given to the end user. So here also, when we talk about the measuring the performance with two parameters, uh, high throughput computing, okay, high throughput and high performance. So for every for every 10 to 20 years there is a drastic change. If we observe that history graph, there is a drastic change. Okay, the scale was being changing with respect to 1 to 2 decade. Okay, see, basing on that we can carry out high throughput computing, high performance computing. When I talk about throughput, so what are the advantages there? So throughput means what? We require more output. At that time, more file sharing concepts can be carried out. When we are going with performance, high speed is given. Okay, so high speed is given in speed of the execution, or in order to get a complex problem, complex analysis problem to be carried out. As I said, now performance with respect to scientific applications. Okay, with respect to certain medical applications. So a lot of, okay, n petabytes of data has to be analyzed there. So at that time performance gives a importance there rather than the throughput. Next, so high throughput computing, where we can utilize them? Okay, in distributed environment. In distributed environment we can utilize the high throughput computing. When we talk about high performance computing, so we can utilize that one in a centralized environment. So when I talk about centralized environment, that means what? So there we are having a client server concept. So for even for a small thing also we have to take the permission. So okay, so that is the centralized centralized control environment and distributed control environment. Next, when we go with throughput, okay, geographical sparse means what? With respect to any location, with respect to any kind of location, we can carry out the throughput. Okay, but when we talk about the performance, okay, we have to talk with respect to clusters. Only at available clusters only we can have the performance. Okay, not at all the places. Okay, next, see, there are certain applications with respect to throughput, we are having good applications. With respect to performance, we are having good application, but we require certain cases where we need a combination of these throughput and processing. Okay, so when we combine these two concepts, okay, so then we can access the concept of data grid. See, what is meant by grid? Whenever we talk about the term grid, so that is nothing but an electrical concept term. Grid means what? Electrical grid. Suppose when we divide our country into north side, south side, so for every division there is a grid. So whatever the power that is generated with respect to those areas from dams, okay, thermal, whatever it may be, that power is stored at one place. Okay, that is nothing but called as a grid. So there is a continuous supply to the grid. So here we are calling that one as data. That was an electrical concept. So here, see, that grid is nothing but what do we observe in that grid? Huge amount of power is stored. When we talk the same with respect to the cloud, what do we observe? in that grid is nothing but here pool of resources. Okay, we get the concept. That is nothing but the pool of resources here. There we get the electricity from that storage place. Here we get the required resources. Okay, so that's the comparison. Okay, so here computational and data grids. See next, high throughput computing, where we can utilize that one in SOA. SOA is nothing but stands for service oriented architectures. So depending on the services, depending on the end user, depending on the organizations, so every organization is not going to take or that means borrow same kind of services from the cloud. So depending on the service, there is a different architecture. Okay, for education purposes, okay, for scientific purposes, or for spatial, doing the scientific experiment with respect to space data. So there are different service architectures are there. So such kind of thing we can carry out with the throughput computing. Next, when we talk about performance, okay, so we can carry out those with respect to in IoT devices such as radio frequency, okay, uh, identity devices, sensors. So there we can utilize that one. See next, we can utilize the more part of the throughput computing in web services. Okay, so next, performance with respect to IoT, okay, Internet of Things. So we can also utilize the combination of these two with respect to certain internet clouds. Okay, so that's the two parameters. So what Linpack scientist has said that there are two parameters basing on which we can measure the performance of a cloud. So that is nothing but one is HPC, another one is nothing but the high throughput and high performance. So both are different. Both are having their own scenarios. Both the applications are also different. The end user applications are also different with respect to both kind of computing. Okay. So there are certain cases where we require the combination of them. Okay, that we come across in the next topic. See next, high performance. See performance, as we are saying now, performance is nothing but a number of operations that are being carried out. So in 1990, that means the limit was with respect to gigaflops. Okay, so how can we measure the performance of a system? That is nothing but the flops, floating point operations. Okay, so next, so that has reached to petaflops in 2010. So that was the drastic changes or advancements that has been carried out with respect to the performance. Similarly, with respect to throughput, okay, due to see as more cloud applications has to run with respect to application oriented. So at that time we require throughput, okay, rather than making a complex analysis where we require performance. Okay, so for various applications we require the throughput. Okay, so next, computing paradigms. When we talk about a cloud, so end users are not carrying out the same kind of resources. Okay, so with respect to the applications, they what they need, so they have to carry out different sort of computing. Okay, what are they? So just have a look here: centralized computing, parallel computing, distributed computing, and then comes the cloud computing. So that means this was the trend that has been followed out. First it was centralized computing. When we talk about the centralized computing, where do we come across the centralized computing? See just if you go back, see here we are having centralized control. Okay, so in performance, high performance computing. Centralized computing is nothing but that that is a client server concept. So for everything, to access the resources, to execute the application, we have to take the permission. One, until unless the permission is not granted, we cannot carry out any sort of thing. So that is nothing but the centralized computing. Parallel computing, so here in parallel computing we can run many applications at a time. At the same time, what do we observe? The processors which are used, they are directly connected with the memory. In distributed computing, so in order to enhance, see in centralized computing there is only a single memory that is attached, and everything has to be carried out with respect to that single memory. To overcome that, so there are certain drawbacks. Okay, to overcome that we have moved to the parallel computing. So again from parallel computing also there are restrictions. We cannot get the required efficiency. We are unable to reach the required efficiency. So then we have moved to the distributed computing. In distributed computing, what do we observe? Every system is having its own memory. Every system is connected to the computer network. It is So to access or to perform any sort of work in distributed computing, there is no need to take a permission. Okay, we can carry out. But then also the performance or the efficiency was not reached. The lagging thing was nothing but the sharing of the resources. So now, what is the basic concept of the cloud? So why the concept has been, the technology has been famous there? So nothing but the sharing of resources. So then comes our cloud computing concept. Okay. So first, computing paradigms. So different computing, okay, concepts was being carried out at the starting. Centralized computing. So there, to get the output, even to carry out the small tasks also, we need to have a permission. Okay. So that was a drawback there. Next, in order to overcome that, to enhance the performance, to reach the targets, okay, so then come into the picture the parallel computing. In parallel computing also, what do we observe? See, some of the or all the processors are connected with the, coupled with the memory. So next, distributed computing. Distributed computing, each and every system is having its own processor. Every system is having its own memory. Okay. Next comes the cloud computing scenario. So there we have enhanced the performance. There we have enhanced the efficiency. Okay, to get the task done. So these are the 3 or 4 computings. Okay. So after uh, going through the centralized, parallel, distributed, then at last we have reached the concept of cloud computing. So next, distributed families. So as I said now, that there are certain applications which are good to be carried out with throughput computing. There are certain applications which are good to be carried out by performance, but there are still certain applications. That means when we go with the concept of supercomputers, so there what happens? Both the factors play an important role. We want the more output, at the same time we want the high performance also. Okay. So processing also important and high throughput is also important. In such kind of scenario, we require the combination of both HTC and HPC. So that is nothing but distributed system families. So there what do we observe? So the, as the example what we have been saying, that is nothing but a supercomputers. In such kind of scenarios, for those application to be carried out, we require certain objectives. What is that? We should have a efficiency, dependability, adaptation, flexibility. Okay. So these are the things that should be connected with the applications or the devices or the applications where we are running both the concepts, whether that is HPC, a combination of HPC and HTC. So both the combination, as we have said now, supercomputer. So there we need the importance of both throughput, we need the importance of both the performance. Okay. So such kind of scenario has to be carried out with certain objectives. So what are the objectives that we come across there? One is the efficiency, that is nothing but the utilization rate of the resources. So for how long, okay, for what is the time period for utilization of the resources, whether the resources are being utilized properly or not. That means what? Uh, we say that optimal utilization of resources. So that can be achieved in cloud concept. It is not like that out of the 10 resources, every time 9 resources are being used and one is kept aside. No, it is not there like that. Okay. Optimal utilization of resources is being carried out here. Okay. So that is nothing but the efficiency. Next, dependability. So if we are utilizing the resources without making them idle, so definitely there will be a good quality of service. So that is the dependability. Next, adaptation in programming model. Adaptation in programming model means what? Whenever we are running the application with respect to the cloud platform, what do we observe? Today we are running with respect to one technology, tomorrow we may have another technology. So the configuration that we have gained from the cloud, it doesn't mean that it works only for today's technology. Okay, it is not useful for tomorrow. It's not like that. Okay. So the architecture or the services that are being uh, created or being delivered with respect to the cloud, they are working with the present technology, they are working for the coming technologies also. So that is nothing but adoption in programming model. Okay. So it is not that for the working with respect to today's technology only the concept is being confined. It's not like that. Okay. So new technologies can be adopted, they there also we can get the same performance as that of the previous one. Next, flexibility in application deployment. See, suppose we are running an application that works on a particular platform. If you want to run the same on another platform, then also what happens, we require a flexibility. Those applications can be deployed on various cloud platforms. Okay, so these sort of objectives should be satisfied, okay, for the applications which are running with respect to both high performance and both throughput. Okay, so for an application that is being carried out with respect to performance and throughput, we have to, okay, we have to verify whether these objectives are being satisfied there or not with respect to efficiency, effective utilization of the resources. Okay, so there we are not making any resource to sit idle. So dependability. So here what happens, when all the resources are being utilized, definitely with high output we are getting a quality of service. Next, depending on the requirement, okay, new technologies or new operating systems are easily adaptable. At the same time, the deployment of the application is also carried out on an easy way on different platforms. Okay, so these are the concepts that we come across with respect to distributed system families. See here, scalable computing trends and new paradigms. We have observed the computing paradigms. Okay, so with respect to different computings we come across, from centralized through parallel through distributed, at last we have reached the cloud computing. So what is the main concept there? Nothing but to run, the sharing of the resources should be optimal. Okay, so as more and more resources are shared, then we can get more throughput, more performance with that too with quality of service. See here, suppose we want to execute a job. Okay, we want to run a particular job. So what is the job? A job is nothing but a combination of at least one or many tasks. So again, when we talk about the task, what does the task consist of? It consists of certain data that has to be manipulated, that has to be certain operations has to be carried out with respect to every task, with respect to the data that is being confined to the task. So when we talk about the data, to perform an operation on the data, we require certain instructions. Okay, we require certain instruction. When I talk about the instruction, so instructions can be executed at bit level, one by one instructions. So no, we are not saying that all the instructions are being executed. So now just go to the scenario. To a job is a combination of tasks. Okay, a task is a combination of data. Okay, a data is a combination of many instructions. So again, each and every instruction is nothing but there we are having a bit level of instructions. Okay, bit by bit, okay, instructions are there. So these are the degrees of parallelism. Okay, in order to execute the applications, some of the applications may be executed at bit level, next instruction level, next data level, next task level, and job level. The simple scenario here that we have to remember is nothing but job. Okay, uh, when we can say that a particular job has been completed, when all the relevant tasks with respect to the job has completed, when we can say a particular task is completed, when all the relevant operation that has been carried out with respect to the data are being completed. So in order to complete the operations on the particular data, okay, to do the manipulation with respect to the present data, to enhance the task, in order to read the job, to complete that job, we require certain instructions. Okay, so how the instructions are being carrying out here with by giving a bit level. Okay, bit level instructions. Okay, so every instruction is again divided into a bit level. So the degree of execution is carried out from bit level to job level. So that is the thing that we have to learn here. So this is how we are going to get the applications being carried out in the cloud from bit level to the job level. So innovative applications. So as I said now, so with respect to throughput, we are having certain applications which are being executed. With respect to performance, we are having certain applications. So there are certain situations where we require the combination of both. So what are they? So these are the fields, okay, in scientific and engineering, business, education, internet and web services, mission critical application, where we require the importance of both the concepts are there. When I talk about science and engineering, okay, so as I said, simulation task we have to carry out. In simulation, lot of data is being analyzed, okay, so earthquake prediction, weather forecasting. So these kinds of scientific application requires a lot of data to be analyzed, okay, huge petabytes of data that has to be analyzed. But and we have to get the result at a short span of time, and the analysis should be carried out without any error. So how these concepts can be reached here? By the combination of this HPC and HTC. Okay, so here with respect to scientific and engineering purposes, so these are the application. When I talk about the business, education, service industry, so what are they? Telecommunication service, in air traffic control, electric power grids, we have to maintain them properly. Okay, so in such kind of situations, we can use the combination of both HPC and STC. So again, in internet, okay, to maintain the data centers, we have to develop a critical decision making systems. Okay, next, mission critical application. So mission critical applications are nothing but we have to reach the target and complete the task. So where we can observe these kind of applications, most probably in military command and control, during the crisis management. So now, okay, the crisis is being going on, so we can apply these okay, with respect to the combination of HPC and HTC, we can manage that one very effectively. Okay, so this is the degree of parallelism, and these are the innovative applications that we can achieve, as we have said now. So with respect to throughput, we are having good application. With respect to high performance, we are having good applications, but there is a need for certain application to run on a combination of both. So what are they? So these are the domains, and these are the relevant applications which are relevant to the domains. In scientific and engineering, we can use the combination of HPC, HTC. With respect to business education, we can use the combination of HPC, HTC. Okay, with respect to internet and web, mission critical application. Okay, so that is about the innovative applications, a combination of both the things. Next comes utility computing. Okay, this is a new term, utility computing. So utility, the term indicates that means dedicated to a particular. That means what, here when an end user enrolls with respect to a cloud, he has to complete his task. Okay, for that it dedicated resources. Okay, the required resources are dedicated for the completion of the task. So such kind of scenario, or the such kind of computing is nothing but called as utility computing. So that is nothing but it focuses on the business model in which the customer receives computing resources. That's what we have said now. So there is a cloud service provider, okay, depending on the need of the end user, maybe an organization, okay, maybe a single user, whatever it may be. So in order to complete their task, a dedicated resources are being dedicated for that. Okay, resources are being dedicated for that in order to carry out the computing there. Such kind of computing scenario, we can term that one as utility computing. Okay, so what do we come across in these kind of utility computing paradigms, and what are the different technologies which are being associated here? So again, when we talk about the utility computing, so both importance of both the throughput, importance of both the performance is given. Okay, so that thing we should remember in utility also, both throughput and both high performance, high throughput, they both give a importance. Okay, so next, what are the computing paradigms that we come across here? We can go with various web services. Okay, various data centers can be managed easily. Okay, yeah, utility computing, service computing, grid computing, P2P computing. Okay, cloud computing. So these kind of scenarios can be carried out. Next, they are unique. Okay, next, we can perform even very simple operations also. Next, whenever we are performing the computing with respect to utility, definitely we have to see about two things. One is the quality of service, another one is the SLA. So what is meant by SLA? SLA is nothing but plays an important role. That is nothing but a service level agreement. I think whenever you open a application for the first time, there is a checkbox that terms and conditions. Okay, generally we won't refer, or there is no much time for us to refer those terms and conditions, just we accept that one. Okay, so what is that one? That is a service level agreement. In the same way, when a end user or an organization enrolls with a cloud to carry out certain application with respect to the resources being shared, so there is a SLA, service level agreement. So client requires that he should get achieve maximum utilities from the, or maximum resources from the cloud, so which a cloud assures to the client or end user that definitely it will provide the resources, and the costs are being varied depending upon the usage of the resources. So when a end user, okay, first time when he enrolls with respect to a particular cloud, there is an agreement that is being carried out. So that agreement is nothing but called as a SLA, service level agreement. Okay, so that is the service level agreement. So for all the kinds of tasks which are being carried out, we should give, or we should enhance the concept of QoS, quality of services. So these are the things which are very important with respect to the utility computing. Okay, it is a combination of both HPC and HTC. At the same time, we by utilizing the very trending computing technologies, we can carry out. At the same time, they